What's up guys, this is LeetCode 26, remove duplicates from sorted array. Given a sorted array, nums, remove the duplicates in place such that each element appear only once and return the new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with constant extra memory. So example 1, your function should return length 2 with the first two elements of nums being 1 and 2 respectively. It doesn't matter what you leave beyond the return array. So let's try to understand here. The exercise is asking us to return the length of the array after we rearrange it. Yes, so we actually have to rearrange this array. As we are seeing here, we have duplicates in a sorted array, and we have to put all the duplicate numbers in one side of the array and all the remains into the other side. And after that, we have to return the length of the subarray that contains all the numbers that has no duplicates. Yes, so if we check here, 1 is equals to 1, 1 is not equals to 2, so we just need to swap 1. We actually don't need to swap, we can just put the number 2 here, and this way we'll have 1 and 2 both not duplicates in one side of this array, and the length of this subarray is 2, which is the answer here. Yes, so in example 2 we have a lot of duplicates, but I think the solution will be the same here. Yes, we are just, as I said before, we are just rearranging the array, putting all the not duplicates in one side and all the duplicates in the other side of the array. Clarification: confused why the return value is an integer but your answer is an array? Know that the input array is passed in by reference, which means modification to the input array will be known to the caller as well. Let's just explain how reference input works. Yes. Okay, so I think we can solve this by storing the last valid index in a variable and by checking if the current value is different from the next value. If it is, we can set the next value to the last valid index. So we're gonna do that till this number in the array. Yes, I think that's it. Let's try to write some code and see how this works. Let's first start checking if the input is valid. So if nums length is equals to 0, we can assume that we do not have any numbers in this array, and we can return 0. And also, we can start by declaring the variable. I said we would need to store the last valid index, so last valid index is equals to 1. Is equals to 1 because we can assume in an array that has duplicates, even if both the first two numbers are duplicates, we can assume that this one we have to let it here because we will just change the next one. Okay, so this is why the last valid index will start with 1. After that, I think we can start our iteration through the array. So ri is equals to 0, while I is less than the nums dot length minus 1, and this is minus 1 because we will compare the current number with the next number, and I plus plus. So yes, now we need to start our checks. If the current num is different from the next one, we can change. I'm seeing the example here. So if we are here, so the current number is different from the next one, we will compute we will set the next one to the last valid index. But in this case, both are equals, so we will not get in this if statement. We will just continue the iteration. But here, in this case, the current number is different from the next one. So we will set the I plus 1 index to the I plus 1 value into the index of I plus 1 to the last valid index, which in this case is 1. Yes. And also we need to update the last valid index to be the next one. Yes, so we can do this by last valid index. We can also already update it. It's equals to input of I plus 1. So by the end of this iteration, the last valid index will contain the length of the subarray which has no duplicates. So we can just perform the return last valid index here. And I think that's the solution. Let's try to run the code. Input does not exist, so it's not input, it is nums. Nums, okay. Last valid index, last valid last. Okay. That's the solution for this input here. Let's try this one. And that's the solution also for this one. Let's try to hit submit. Okay, that's it, guys. So time complexity here is big O of n, where n is the length of nums because we are iterating throughout this array. Memory complexity is constant, it's big O of 1, because even if we are declaring here one variable, this variable does not have anything related to the growth of the input. Yes, so we can also make this solution into a recursive one. And it is pretty easy because we can make it as a tail recursion. We can do this. Let's just try. So we can remove this one. We can create a helper function like private in remove loops. We will need here an array of nums, which is our input. We also need the I index and also the last valid index. Okay, so we are gonna start with our base case, checking the base case of this recursion, which is if I is equals to nums.length minus 1, which means that we get to the end of the array, to the last but one index, and when we get there we need to let me see, yeah, we need to return the last valid index as before. After that we can compute our check the same as we did before, like if input of I is different of input of I plus 1, we need to perform the setting. We need to set the input of last valid index to be the input of I plus 1. So the input of last valid index plus plus is equal to input of I plus 1. And after that we can call our recursive function. So we can just return remove loops with nums and I plus 1 and also last valid index. Yeah, I think that's the solution, and we just convert the iterative solution into a recursive one. Let's just call this recursive function here. So return remove loops to be nums I will be 0 here, and last valid index will be 1, as we did before in iterative solution. And I think this will be the solution. Let's try to run the code and see the results. It's taking some time. Let's go. Yeah, it's taking too much time. Let's see if we have any error here. Input does not exist. Input. Oh, again, I use input. It's not input, it's nums. Let me see. I use the input everywhere, so I will just change nums to be input here. So, and here. Because here input, yeah, and here. I don't know why I did this. Input. So let's try to run code again. Input last valid index does not exist, so it's last valid IDX. It's not index. A lot of typos here, a lot of errors. Also here, oh my god. Index. Last valid index. Yes. Let's try again. Okay, so let's try to hit submit for this solution. Index all of. Okay, so we just forgot to check here if nums.length is equals to 0, we just need to return 0. So we can first check for this case before we hit submit. So for an empty array, we can check if the result is as we expect. Yes, so let's try to hit submit again. And that's it. So this is the recursive solution, and the time complexity here is also big O of n because we are iterating through all this input. And memory complexity here Different from the other solution, here we have a memory complexity of big O of n because of the allocation of all these recursive calls into the stack. So if you consider a stack being a memory allocation for this solution, and you also have memory complexity of big O of n. So that's it, guys. Thanks for watching.